Alrighty, welcome to day 11. In our planners, let's be writing down day 11 for the homework. Have your homework out so you're ready to check the answers, and you can be giving the warm-up a try. This one is pretty similar to the second last one that we did in class on day 10. So as you're doing the warm-up, feel free to flip back to that on the notes from last class if you're having trouble. But we are going to pause the video for 3 minutes to allow you to do that. So we want to set up our right triangle. I'm going to make my theta down here. Cosine is adjacent over hypotenuse, so 2 square root of 14 would go here, and hypotenuse is 9 over there. We want to do Pythagorean theorem, so I'm going to do 2 square root of 14 squared plus b squared is equal to 9 squared. 2 square root of 14 squared, remember to put that all in parentheses and then square it in the calculator, so we get 56 plus b squared is equal to 81. We can subtract that 56 over, and we would get b squared is 25. Undo the square by taking a square root, we get b is 5 for our third side. From there, we want to do sine theta, which is opposite over hypotenuse. Our opposite is 5, our hypotenuse is 9. Does not reduce, no radicals you have to worry about in the denominator, so that's it for sine theta. You can stick your warm-up sheets away, and moving over to the homework. So we had cos is 4/5, so that's your adjacent and your hypotenuse. So your Pythagorean theorem, you eventually get 3 for the third side. Tan, your opposite over adjacent, was 3/4. Sine, your opposite over hypotenuse, was 3/5. Number 2 is like what we saw on day 9. It was nice they gave us the picture. So we wanted to find both of those values, x and y. So to find x, we have opposite for the x. We've got adjacent for the 400, so use tan. Because we're finding a side, put that tan 28 over 1. Cross multiply, the x is by itself. So then we can put that in the calculator, and we're rounding to 3 decimal places. Don't forget to put yards on your answer because we did have units. So that was for BC. For AC, use the 400, which is your adjacent, the y, which is our hypotenuse, so we're using cos. This time when we cross multiply, though, the y is not yet by itself. You have to still divide by cos 28. So sub in the 40 over cos 28 in the calculator and round to 3 decimal places. Sine is opposite over hypotenuse, so label those two sides when you do Pythagorean theorem. We eventually get square root of 110. If you do a menu number factor, that's 2, 5, and 11, so nothing that will simplify for us. So label your third side. Cosine is just adjacent over hypotenuse, square root of 110 all over 11. That one's in good shape. For tan, you've got square root of 11 over square root of 110. So there's a couple ways that you can handle that. One, you could put it all under one, the fraction all under one square root, reduce it, and then rationalize. But what I'm guessing more people did is took this and multiplied top and bottom by square root of 110. When you multiply in the numerator, we should get square root of 1,210 over 110. When you do menu number factor for that radical, you're going to get 2 times 5 times 11 times 11. So one of the 11s goes out front. So this will become 11 square root of 10 over 110. Then reduce 11 tenths, and that gives you 1/10, so it's just square root of 10 over 10. For the last one, this picture can be a little bit tricky. So we want to find the height of the pyramid, which is the straight up and down height, the h there. Well, we want to find opposite. We know the hypotenuse, so use sine. Cross multiply, get the h by itself. To the nearest tenth, we have 8.2. Find the lengths of the sides of the bases of the pyramid. Well, this is the tricky part. So notice this side all the way across, that's what we're looking for. But in our right triangle, we only have this, which is half of it. So I called that x, and then our actual side in the triangle will have to be double that. So if you do cosine, using x as the adjacent and 9 as the hypotenuse, cross multiply and solve, you get x is 3.6 and change. And then bring it up here, and you got to double it, and then round to the nearest tenth. Don't round to the nearest tenth till you get to your final answer. We're going to be on page 58 to start out, so if you could flip there and also have your calculators ready to go. So, area of a triangle, you should have seen in middle school at some point, is 1/2 base times height. Now, if you're using that formula, the base and the height have to form a right angle with one another. They have to be perpendicular to each other. So in this first triangle, we can do 1/2 times the base of 20 times the height of 8. Well, half of 20 is 10, and 10 times 8 is 80, so we would get 80. They didn't give us units, but we've got an area, so we would want to say units squared. 20 is the base, 8 is the height, because they're forming a right angle with each other. In the second one, we can do 1/2 times the base of 5 times our height of 12. 5 is the base, 12 is the height, because they're forming a right angle with each other. Well, here to think through this one, do half of 12 first. Half of 12 is 6, times the 5 is 30, so you get 30 units squared. In the third one, we could do 15 as the base, but then we don't have a height that's forming a right angle with it. If you use 12 as the base, we don't have something forming the right angle with it. So what we need to do here is we will need to find the actual height. And that's what we're going to do down in the bottom of this page in your packet. So this is the same picture as that third one. What we're going to do is we're going to draw in the altitude. Altitude goes from the vertex and forms a right angle with the other side. Well, what we're going to do for a second is we're going to ignore the big picture. And let's work with this triangle where we just dropped the altitude. And what we want to do is we want to find that vertical length. So let's call that x. So we're using the red triangle there. From the 42 we have opposite, and the 12 we have is hypotenuse. Keep in mind this 15 was for this entire side, so 15 is not part of the red triangle. So in the red triangle, opposite and hypotenuse will do sine of our angle 42 is equal to x over 12. Well, if we cross multiply, 1 times x is x, we'll get 12 sine of 42. And what we're going to do is we're going to just leave it as that for right now. So x is just 12 sine 42. It's just some number. It'll be some decimal likely that goes on forever. Well, now we have that vertical length. We just found this length, which we needed to find the area. So our area now is equal to 1/2 our base of 15 times our height, which is 12 sine 42. Okay, 12 sine 42, just a number. We can put it in the calculator. If we type that all in, we're going to get 60.221 and some other stuff. And we wanted to round to the nearest tenth. So this area would just be 60.2. It's an area, so we'd have to say units squared. Now, if they had told us our lengths were in inches, say, we wouldn't say units squared, we would say inches squared, because we would actually know the units. But what we want to do is we want to try and generalize this. So we had the 1/2 out front. Notice 15 was one of the sides in the original triangle. Notice 12 was one of the sides in the original triangle. And notice then we did sine of the angle that's in between them. So in reality, we can shortcut this to find the area of any triangle, does not have to be a right triangle, if we can just do 1/2 side times side times sine of the angle that's in between. And that's what we're going to see on the next slide. We've got this general triangle drawn in here. If we wanted to find the area of that triangle, one thing that we could do is we could take this side. So we'll do area is equal to 1/2. We'll call it little a. Then we'll take another side. That one's called little b, times sine of the angle that's in between them. Well, the angle that's in between them is just capital C. So we have area is equal to 1/2 AB sine of capital C. And maybe we should just specify in here that it's area of a triangle. So what I'd like us to do is let's go to the back of our packets where we list stuff that we want to study from, because this is something that we will have to memorize. So the first thing I'd like you to write is this exact thing. So area of a triangle is equal to 1/2 little a times little b sine of capital C. Sides are always represented as lowercase letters. Angles are capital letters. And then what I'd like you to do is we're going to write it in a different way as well. So right underneath where you write area of a triangle equals and the 1/2 AB sine C, I want you to write it as 1/2 side times side times sine of, and we're going to write angle between. So that's really what we're doing. If we want to find the area of any triangle, it does not have to be a right triangle, we can do side times sine of the angle that is in between. So we could have done A and C for our sides, then done angle B, or we could have done c and little b for our sides and done big angle A as our angle. It doesn't matter, we just need to do 1/2 side times side, sine of the angle in between. So if we move down to the bottom, we've got a farmer. He's planning how to divide his land for planting next year's crops. And a triangular plot of land is left with two known side lengths measuring 500 and 1700. So let's just draw some random triangle. And they tell us that two of the sides are 500 and 1700. And that's not to scale, obviously. And those are meters for each of those. Well, what could the farmer do next in order to find the area of this plot? Well, if we look back to what we wrote on the back of our packet, these two things, he has a side, there's another side, just needs the angle in between. So, what could the farmer do? The farmer could measure the angle in between. So let's flip over to page 60, and we're actually going to look at question 5 first, and then we'll come back and have you try 4 on your own. So a landscape designer is designing a flower garden for a triangle area that is bounded on two sides by the client's house and driveway. So let's just draw some random triangle. So maybe this side is the house, and this side is the driveway. The lengths of the edges of the garden along the house and driveway are 18 and 8 feet respectively. If you're not sure what's meant by respectively, that just means in the same order they were stated. So house stated first, driveway second. So the 18 goes with the house because that was first, the 8 with the driveway. So we'll put 18 feet over here, 8 feet for the driveway. And the edges come together at an 80-degree angle. So they're meeting here at 80 degrees. So we've drawn our diagram. We now want to find the area to the nearest square foot. Well, as we wrote on the back of our packet, area of a triangle is just equal to 1/2 side times side. And I'm not going to have room here, but right there we would do sine of the angle between. So our area is just going to be 1/2 times, we have two sides, so we'll do 18 times 8 times sine of the angle that's right in between, 80. So we want that to the nearest square foot. So we'll give you a minute to punch that in. Once it's punched in, round it to the nearest square foot and make sure to have units on it. So we should have gotten 70.90 and some other stuff. So to the nearest square foot, that would be 71 feet squared. So it really just comes down to, if you know that formula, 1/2 side times side, sine of the angle in between, it's a pretty easy problem from there. So what we're going to do is we're going to go back to 4, and we're going to pause the video, and we'll give you 2 minutes to see if you can do this one on your own. When you think you got the answer, if your neighbor does as well, compare and see if you're in agreement. All right, we've got a triangle. We want to find the area. So area should be 1/2 side times side times sine of the angle between. So that means we're going to have the area as 1/2, 3 times 7 sine of 49. So that gives us 7.924 and some other stuff. So we should have gotten to the nearest tenth, 7.9, and make sure you have on there units squared. All right, moving to page 61, one last problem. Now, let me preface this problem with, this problem is harder than things you would usually see on homework or on a test, things like that. So those last two examples are about the difficulty level you would see with this type of problem. So we want to find the area of this triangle. Notice that we don't have two sides though. We only have one side. So if you don't have two sides, we basically have to go back to how we did this originally. So what we'd have to do is we'd have to draw in an altitude. And now we could think of as 11 as our base, and this is our base here, and this is our height that we need to find because they'd be perpendicular to each other. So what we're going to do is off to the side, let's set up that bottom right-hand triangle. So this is 71.45 degrees. That's our right angle. That's H. And because this is isosceles, when we draw in the altitude, that should split this into 5.5 for each of them. So this bottom side here would be 5.5. Well, we can do regular SOHCAHTOA here. From our angle, we have opposite and we have adjacent. So this would just be tan of 71.45 is equal to our opposite h over our hypotenuse of 5.5. If we cross multiply, h is just going to equal 5.5 tan of 71.45. So that's just going to go there. And we could punch it in, but then you got to write a lot of decimals, so let's wait to punch it in. Well, now we just have our basic area of a triangle formula that you've used in years before. 1/2 base times height. And the reason we can use that is we've got the base and the height now that are perpendicular to each other. What we did on those last couple problems is, if you don't have a base and height that are perpendicular, we could do 1/2 side times side, sine of the angle between. We couldn't do that here because we didn't have the second side, so we had to go about it this way. So our area is just going to be 1/2. Our base was 11, remember, all the way across, times the height, which we just found was 5.5, tan of 71.45. When we punch that in, we get 90.146 and some other stuff. Look to see where you wanted to round to. We wanted to the nearest tenth. So 4 would keep it at a 1, so we'd have 90.1 units squared. So the remainder of the period, you can be either working on your homework or problem set. Come test day, you'll want to make sure you have that formula for area of the triangle memorized. Have a great rest of your day.